Hey guys, we are looking at section 012, mean, median, mode, and range and quartile. So there's a lot of vocabulary that you're probably not familiar with, but that's okay because it's going to be easy. So the mean, I think this one you guys know, mean basically means the average of some data points. So mean is the average, and the average is when you take the sum of all the numbers, so sum of all data, and then you're going to divide it by the number of data points or data entries. Confusing? So let's go ahead and take an example. So if I had 3, 5, 7, 7, 9, 10, and 11, and I needed to find the average of these numbers, I'm first going to add up all the numbers. 3 plus 5 plus 7 plus 7 plus 9 plus 10 plus 11 is going to give us 53, I think. 53, 52? Let's see. I think it's 52, maybe 53. We'll see. These guys come together and add up to 30. Like if I put the 1 there, that's 30. 7 and 7 is 14. And then 3 and 5 is 8. When I add that, I get 50. I get 22 plus the 30 is 52. Yeah, if it's wrong, you'll tell me. I know. All right, so then I'm going to take that 1, 2, 3, 4, 5, 6, 7, right? And I'm going to divide that by 7, and that's going to give me my average. 52 divided by 7 is going to be somewhere in the neighborhood of 7 point something something. So 3 is the remainder of 7. 7 and 3 sevens. All right, so this is the average of the data points that we have here. The median is the middle number when the data is arranged from least to greatest. Data is arranged from least to greatest, all right? Least to greatest. So the reason why I am thinking like I'm not going to move on is because I want to say sometimes you might have 2 data points in the center, and like right now we have an odd number of numbers. So we've got 1, 2, 3, 4, 5, 6, 7. The middle number is 7. The median here is 7. Pretty straightforward, right? But what if we had like, I don't know, 15 here? Then the middle numbers would be 7 and 9. And what we'd have to do is take the average of those two, and that would be 8. Like the number directly between those two middle numbers is the average, and then you'd get 8. I'm going to take this off just to keep us going where we were going. So you'd have to do that. The mode is the number that appears the most in the set of data, and so in this set of data the mode is 7. And if you had like 7 7 and let's say we had 10 10, then the mode would be bimodal because there's 2 numbers that appear exactly the same amount of time, and it's with the greatest frequency. The range, so mode is the most frequent data point. All right, and then the range is going to be the difference between the maximum and the minimum value. So the range in this case would be 11 minus 3, which is 8. So 11 minus 3, which is going to give me 8. So that's the range of data. And quartiles, this is interesting. Quartiles is probably the word that you really haven't heard of before. So you've got a lower quartile. Technically, you've got a mid quartile, but that's actually the median, and then you have an upper quartile. So let's take our data again, and let's see what we can do. So I've got 3, 5, 7, 7, 9, 10, and 11. I'm going to pick out the median, which is this guy here. The median is actually considered the second quartile. All right, that's the median. So what I'm now going to do is take the information that I haven't already dealt with on the left side of the median, and I'm going to find that median. So the median here the median of this side is going to be the first quartile or the lower quartile, and the median here, which is 10, is going to be the upper quartile, or I can call it the third quartile. All right, so this is a way that we use to, looking at it in terms of quartiles, is a way that we use to kind of look at information, analyze it, and kind of have a sense of what's going on. And then what we have in association with that is what we would call a box and whiskers plot. And what that looks like is it looks like this. You're going to put the median here, which in this case is 7, then the lower quartile value, which is 5, the upper quartile value, which is 10, and then you'd put the minimum, and then the maximum over here. I guess I could put the 3 down here and the 11 here. And so this is a representation of the data that we're working with. All right, so that's how lower quartiles, and this is called a box and whiskers plot. Because it looks like little whiskers, right? No, box and whiskers plot. Nobody's impressed. All right, let's keep it moving. So here's an example. We're going to find the mean of the following numbers. Remember, mean is the average. So we're going to add all these numbers up and divide by 4. So the sum of the numbers is 17, and I'm dividing that by 4. And when I divide 17 by 4, I get 6, and no, I don't. I just made that up, telling you lies. I get 4 and 1/4. Yeah, because 1/4 is left, right? Or 4.25. So 4.25 is another way of looking at the mean. Find the median. So remember, with the median, we need to make sure that we arrange it from least to greatest. So 2, 3, 3, 5, 6, and 7. Knock them off. And the middle number, there's middle 2 numbers. So we need to take the average of these guys. And basically, when we're taking the average of 2 numbers, we're finding the number directly in the center of that. So that's going to be 4. So the median in this case is 4. Find the mode. So mode is really helpful if we just kind of take a look, and we can sometimes eyeball it. Sometimes it's helpful. I see 79 once, 79 twice. I see 76, 76. Anything else? I see, use a different color. I see 78, 78. Anything else? I see 72 and 72. Looking for the one that I have the most of. I don't know, people. 78. Oh, there's another 78. And it looks like the 78s have it. So 78 appears the most out of all of these other numbers. All right? All right, example 2. Yoko earned the following scores on her math test: 82, 96, 92, 83, and an 81. What must she earn on the 6th test to have an average, a mean of 90? Now, the thing about this question is that it appears like all the time, particularly in standardized tests. So I know the SATs are a little bit far off, but this is like one that I have taught 1,000 times in my SAT prep courses. So what I need you to do is make sure that you can kind of follow along with the logic, not just to do it here, but also because you want to make sure you understand it, because you will see it again, all right? So we've got these 5 tests that were taken. And so when I think about it, I like to think, so I actually like to write down what I would do. I'm sorry, this should be a 96. I'll do this again. I like to write down what I would do if I had all the information I needed, so I can see if I can unprocess and figure out how to do it without the information I needed. And you'll see what I mean in a minute. So I've got this, that, and this, plus some unknown test, right? Some unknown test that we're hoping to figure out. And what we want to do, we know that when we divide it by 6, because when we take the average of her 6 tests, we need to divide it by 6, right? All 6 tests. Then she wants it to equal 90. So what I'm actually trying to figure out is what this number is, and how can I do that? In a sense, this is just an X value, right? And what we need to do is undo all the things that we can do to get X alone, because that's how we solve all problems. So the first thing I'm going to do is I'm going to simplify this by adding up all these numbers. Okay, so we've added those up, and we see that we have 434 plus X. So all of this is 434 plus X. Over 6 is equal to 9. So what we need to do is kind of undo what's happening to X. The first thing we're going to do is get rid of this 6, and then we're going to get rid of the 434, because this whole thing is being divided by 6. So we're going to undo that. To undo that, I'm going to multiply both sides by 6. Swoop delicious. 90 times 6 is 540. So I'm getting my answer, and it's not looking great for Yoko, right? You know why? Because if I subtract the 434 from both sides, I get that my good friend Yoko needs to get a 106. Now, if she's not getting extra credit, that 90 will not be in her future unless she can do some other cool things in her class. So she needs to get a test that's 106 points in order to get a 90 in the class. So do you guys see what we did? What we did is we thought about how many points. In a way, this 540 is how many points you need to have on 6 tests in order to get a 90. And then we basically just took the amount of points that she got on the other test and subtracted that, so which was 434, subtracted that in order to see how many points she needed to get on the final test. Not too bad. keep that one in your back pocket. You're going to want to keep that in mind. And finally, we have, I think this is finally, yeah, last example. Finally, we have a situation where we get to look at the median, lower quartile, upper quartile range of the data shown. And I'm going to rock a box and whiskers plot, even though they didn't ask me for it. We'll do it anyway. So the first thing we want to do is order the numbers from least to greatest. Okay, so now that that's done, we're going to find the median. Since there's 11 data points here, or data bits of data information, 1, 2, 3, 4, 5, 6 is going to be the center. Let's check it out. 1, 2, 3, 4, 5, 6. All right, so 21 is my median. Next, we need to find the median of the data that's over on this side and the median of the data that's over here. It's not really called the median. This one is going to be called the lower quartile. So I'm going to go right here to the center, and this is the lower quartile. And this over here, 28, will be my upper quartile. And obviously we can find the range of the data by taking 35 and subtracting 14, and we would get that the range is 35 minus 14 is 21. Yeah, making it up? No, not really. Okay, so we get 21. The box and whiskers situation that we have here would put 21 in the center. We would go all the way out to 28 to the upper quartile, go back down just a bit to 17 for the lower quartile, and then rock in the ranges. We go as high as 35. Let's put the 35 down here. And we go as low as 14. Okay, so I think there's a problem where they say they ask you to write it out as a box and whiskers plot. And so I just wanted you to know that it's not that deep. It really is just taking that data and putting it in that in this physical structure. Is that all right? Good stuff. I look forward to talking to you guys soon. Let me know if you have any questions. Bye-bye.